Hello, welcome back to this series on differentiation. So in the previous episode I looked at using differentiation to find the maximum and minimum on a graph, which are also the turning points. But at the end of that video I said there was another type of turning point which is known as a point of inflection. So this is two examples. We have y is equal to x cubed and y is equal to the minus of x cubed. And these are what the graphs look like. And as you can see, at this point here and here, the gradients, so dy by dx, are equal to 0. Of course, this is not a maximum or minimum because the graph then keeps going up, or in this case, keeps going down as you go to larger numbers of positive x. So the question is, does differentiation to find these turning points still work? So the answer is obviously yes. So we can do dy by dx is going to be equal to 3x squared, and we're going to say that that is equal to 0, in which case x is also 0. And if we do that for this one as well, so we end up with dyx is equal to minus 3x squared, which we're also going to say is equal to 0. This will also give that x is equal to 0 for this example. Of course, I picked this example for simplicity, but to show you what's going on. So we know that the turning point is at x equals 0. We can see that from the graphs as well. The question is, what happens when we do the double differential? So I'm going to write this as y double prime. So let's differentiate this again. So we're going to be doing the double differential of this, which is the differential of this. So the 2 is going to come down and we're going to end up with 6x. And in this case, what we're going to end up with is the double differential, or y prime, or double prime, is equal to minus 6x. So if we now plug in the turning point, which is 0, we're going to end up with this at 0. So we're going to end up with y double prime is equal to 6 times 0, which is 0. So we've got the double differential is equal to 0. And this is going to be the same on this side as well. So in the previous video we said if this number comes out as positive, it's a minimum. If it comes out as negative, it's a maximum. However, when it's 0, it means it's a point of inflection. So that's what the inflection, how we determine the point of inflection, or the nature of the turning point. We can say it's a maximum, a minimum, or a point of inflection, and that will depend on whether the sign in front of the number that comes out from your double differential is positive, negative, or 0. The next question is how do we know which way the point of inflection is going? So whether it's going to be going to positive with the x values or negative. And the simplest way to do this is to put in a number slightly less and slightly bigger than your 0. So if I put in a number, say let's put into this formula, x is equal to 0.1. So if I put that into this, so y is equal to 0.1 cubed, what I end up with is a positive value. Therefore I know that my graph is increasing, so I know it's going to be doing this shape. If I do the same on this one, so if I put in x is equal to 0.1, then this would give y is equal to negative value, which is a negative value. Therefore, it's a decreasing slope. So that's the way of seeing if your function at a point is an inflection point rather than a maximum or minimum, and then determine the nature of the inflection point. Anyway, I hope you found that video useful. In the next video, we'll be using some real-world examples of differentiation. Finding that's often used in business, in manufacturing and production, and also to work out profits and or what point you get maximum profit. And also we'll start looking in future videos at using differentiation to find rates and going from position to velocity to acceleration.